Assalamu alaikum wa rahmatullahi wa barakatuh, my dear students. Our lecture today is titled Illustrative Examples on Trigonometric and Inverse Trigonometric Functions. Inshallah, we'll just discuss together some important problems. In fact, we'll make a review for what we studied before with trigonometric and inverse trigonometric functions. But I advise you strongly, before trying to listen to this lecture or to follow it, please, I want you to be extremely acquainted with three things. مطلوب منك تكون ملم جدا 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 بثلاث أشياء. The first thing is the trigonometric ratios of the most famous angles we meet in our real life. As you know, we have the angle 0, we have the angle 30 degrees, which is pi by 6, the angle 45 degrees, which is pi by 4, the angle 60 degrees, which is pi by 3, the angle 90, which is pi by 2, the angle 135, which is 3 pi by 4, the angle 150, which is 5 pi by 6, the angle 180, which is pi. This angle most famous, and we meet this angle frequently in our real life when studying mathematics. So I want you to be so acquainted with their sign, how to obtain their sign, cosine, tan, without calculator. Why? Because it will take a long time for you for each step to evaluate the one of these angles which are frequently repeated in the problem. So you must, before entering this lecture, please try to keep this in your mind, and I supplied many documents for you many weeks ago. So please make a review with these documents before entering this lecture. This is the first thing. Second thing, you must be also extremely acquainted with the important relation of the trigonometric functions, which we studied before either in secondary school or in MATH01, which are, if you remember, the sine of the sum or difference of two angles, the cosine of the sum or difference of two angles, the tan of the sum or difference of two angles, the sine of twice an angle, the cosine of twice an angle, the tan of twice an angle. If you remember, if we have the sum of two angles, we have sine the first, cosine the second, plus cosine the first, sine the second. If it is minus, okay, it's minus. This is reversed in case of cosine. How? Cosine the first, cosine the second, minus plus sine the first, sine the second. In case of tan, it is tan the first plus or minus tan the second divided by 1 minus plus tan the product of their tans, tan A, tan B. In case of A equals B, we have 2A. A equals B, we have 2A. In case of sum, A equals B, to have 2A. In such a case, we have sine 2A is twice sine half this angle, A cosine A. In case of cosine, we have three relations. In this case, A equals B, and we have the plus sign, so we have minus sign. Cosine A is cosine squared A. Sine A is sine squared A. But we have cosine squared plus sine squared is 1, the golden rule. Cosine squared plus sine squared is 1. So we can replace sine squared by 1 minus cosine squared to have 2 cosine squared A minus 1. Or replace cosine squared by sine squared as cosine squared 1 minus sine squared to have 1 minus 2 sine squared A. Okay? In case of 2A, tan 2A, we have 2 tan A divided by 1 minus tan squared A. This is the second thing you have to keep carefully and put it in your mind. Well, also there is still one important thing in these trigonometric relations. If you remember the golden rule, cosine squared plus sine squared is 1. If we divided both sides by cosine squared, we obtain 1 plus tan squared equals 1 over cosine squared, which is sec squared. From which we have 1 equals sec squared minus tan squared. Enter tan to the other side. Or tan squared equals sec squared minus 1. It depends which relation I use when I have the problem. If the same golden rule was divided by sine squared A, we obtain cosine squared by sine squared is cotan squared plus 1 equals cosec squared A. Or 1 equals cosec squared minus cotan squared. Or cotan squared equals cosec squared minus 1. Which one I use depends on the problem you will have, inshallah. So you have to keep in mind the trigonometric ratios sine, cosine, tan of the most famous angles we meet or frequently meeting our real life of studying mathematics. Okay. Also you have to keep in mind these important trigonometric relations. Please. The final thing you have to study before entering this lecture, some basic concepts of the inverse function. If you remember inverse function, and we will concern in this lecture with the inverse function of the trigonometric functions. Okay, but generally if we have y equals some function of x where x is independent variable and y is the dependent variable, this is the original relation between y and x. If in some way we can express x in terms of y, this is called the inverse function. If we can express x in terms of y, this is called the inverse function, where in such a case y is transformed to be independent variable and x will become the dependent variable and معتمد. Okay, this is referred to as f minus 1 y. So x equals f minus 1 y is the inverse function of y equals f of x, but y equals f of x, so we have f minus 1 f of x. Or simply, if we meet with f minus 1 f of x, this is directly put as x. Don't think of this like you add powers. This is power 1, this is power minus 1, the sum is 0. No. This is annotation. As you see, this is a simple proof. For example, when you are asked for y equals x squared, f of x, which is x squared. Okay, so we can express x as root y. Okay, this is f minus 1 y. Okay, so here if we have f minus 1 f of x, this means that you replace y by f of x. You replace y by f of x. So we have root for y, replace y by f of x, which is x squared, which will result is in x. Okay? Also, when you are asked for sine minus 1/2, we are asked for find the sine of that angle, of which the sine is half. Find the sine of that angle of which the sine is half. So it is half. Okay? So when we are met with f minus 1 f of x, we directly write x. Also, as you know, as we started with y equals f of x, but x is f minus 1y. So f minus 1y. So we have y. That is to say f minus 1y equals y. So generally f minus 1 f minus 1 f of some variable equals that variable. Also f minus 1 some variable equal that variable. Okay, as an example for the second case, if we have sine minus 1 or sine x, we are asked for find the angle. Okay, find the angle of what? Of which its sine equals the sine of the angle x. So it is x. So we have tan minus 1, say 3. This is directly 3. Why? We'll ask it for obtain the tan of that angle of which its tan is 3. Also, when we are asked for tan minus 1, tan by 3, this is by 3. Okay, how much? Take care here. In the first case, we were asked about the tan, so we obtained a value. In the second case, we were asked about tan minus 1, which is an angle. We are asked find the angle of which the tan is equal that of the angle by 3. So it's by 3. So take care when you are calculating f minus 1 f or f minus 1. Take care of this, and you have to be aware that there is no separation between them. I mean, you don't have f minus 1 to f. This never be written as twice. No, never f minus 1. This never 1/3. Okay, there must be no separation between these two. Okay? If you are strongly acquainted with these three things, the trigonometric ratios and with the famous angles and with inverse function, so inshallah you will follow the current lecture so strongly and you will understand so much inshallah ta'ala. Let us enter these illustrative examples. First part of these examples discuss you to obtain, it is based on the inverse function. He will give you some inverse function that needs the corresponding angles. For example, he asks you to obtain cosine minus 1 half. As I told you, cosine 60, cosine minus 1 half. When you are talking about the ordinary trigonometric function, cosine, sine, tan, sec, cosec, the argument is an angle. When you ask it with the inverse cosine with the inverse trigonometric functions, you are asked to obtain an angle. Okay. The given is value, and you are asked to obtain an angle. Here is a given a value, given an angle, and you are asked for a value. Take care of this. Okay, so y equals is tan minus 1 x. Here x is a value and the resulting is an angle. When y equals tan x, the given is an angle and you ask it for a value. Take care of this. Now we said what is cosine minus 1 half? Cosine without calculator. What is the angle of which is cosine is half? It is pi by 3 or 60 degrees. Okay? Someone may ask why it is not minus 60 degrees, because we studied that the cosine minus 1 has its range from 0 to pi, has its angles from 0 to pi, not in the first and the fourth quadrant, only in first and the second quadrant, from 0 to 180 only. So actually cosine minus 60 is half, but we didn't consider it when obtaining the inverse. Why? Because it is not on the principal branch. Another example, sine minus 1 minus root 3 divided by 2. In such a case we have negative values. As you see, this is the inverse sine function, and we have domain from minus 1 to 1 and range from minus pi by 2 to pi by 2. There is nothing to refuse negative angles, but here we refuse negative angles. Okay, what is the angle of which its sine is minus 3 root 3 divided by 2? This angle is minus 60 or minus pi by 3. You can check, not calculating using a calculator. Okay. Also asks us about what is the angle of which its tan is minus 1. As you remember, this is the curve of tan minus 1. Our angles from minus pi by 2 to pi by 2. Okay, which angle has its tan as minus 1? It is minus 45 or minus pi by 4. Okay, which angle has sec minus 1? minus 1, which angle? If you remember, this is the curve of sec minus 1. As you see, we have all our angles are positive. Okay, x may be negative, may be positive, no problem. It gives us x as negative value, no problem, but the corresponding angle will be positive. As you see, this occurs at pi. But I don't remember the curve. What I have to do? No problem, no problem. Say y equals sec minus 1 minus 1. Therefore, sec y is what? Minus 1. Sec is 1 over cosine. Okay, so cosine y equals minus 1. Which angle from 0 to pi, its cosine is minus 1, it is pi. So simply, so sec minus 1 is pi. Okay, okay, now we'll have mixed or composite functions. The solution of this function depends on the fact we studied few seconds ago about the inverse functions. These ones, these facts, this fact, and these two facts. Okay, provided that there is no separation, as I told you, provided that there is no separation between them. Okay, the first one is cosine sine minus 1 half. Cosine sine minus 1 half. If it is not in the form, f minus 1 half is not in the form, to say this half, but this is not in the form. Okay, this must be the same. F sine cosine, but this is not the same. Can I transfer from one to the other? Yes, I told you few seconds ago that we have important relations concerned with the trigonometric functions. If you remember the golden rule, cosine squared some angle plus sine squared that angle is 1. So cosine squared equals 1 minus sine squared. So cosine only is square root of 1 minus sine squared. Also sine squared equals 1 minus cosine squared. So sine some angle equals square root of 1 minus cosine squared that angle. Okay, we can make use here. How? We can transfer from cosine to sine as cosine sine minus 1 half equals square root of 1 minus sine minus 1 half squared. Sine cancels sine minus 1, so we have 1 minus 1 over 2 all squared. We have 1 minus 1/4. It is root 3 over 4, which root 3 over 2. Okay. Also, he asks us for sine cosine minus 1 over root 2, the same. I can't solve it directly, but I have to transform from sine to cosine. This is the relation. So we write 1 minus cosine minus 1 over root 2 squared. Okay, this cancels this, so we have 1 minus 1 over root 2 all squared. Okay, so we have 1 minus 1 over 2 which is 1 over root 2. Okay? He asks us for cotan, tan minus 1 half. Very simple. Very simple. I want to transform cotan to tan. Yes, cotan is 1 over tan. Cotan is 1 over tan. So I have tan minus 1 half. Tan cancels tan minus 1. So we have 1 over half, which is 2. Okay? Also, we need tan for sine minus 1, 1/3. We can't write it directly because it's tan is sine. We have to transform tan in some way to sine. No problem. Tan is sine over cosine. Sine minus 1, 1/3. Sine minus 1, 1/3. This is sine cancels sine minus 1, so we have 1/3. Cosine transformed to sine as 1 minus sine all squared. Sine minus 1, 1/3. So it is 1/3 over 1 minus 1/3 all squared. This is 1/3 over 8 divided by 9, which is 1/3 2 root 2, which is 1 over 2 root 2. Okay? As you see, very simple, very easy. Okay? Another one is cosine for sine minus 1, 1/5 plus 2 cosine minus 1, 1/5. What is the value of this? This is the cosine of the sum of two angles. This is first angle, the second angle, as we discussed before. As you see here, cosine angle plus another angle, cosine the first, cosine the second, minus sine the first, sine the second. Okay, so this is cosine sine minus 1, 1/5, cosine 2 cosine minus 1, 1/5, minus sine the first, 1/5, sine the second, 2 cosine minus 1, 1/5. As you see, this is 1/5 directly, only this, but these have to be modified. How? Cosine sine minus 1, we said that it is 1 square root of 1 minus sine minus 1, 1/5 all square. This one, this cosine, we have three relations for cosine twice an angle. Which one is the most appropriate? Which one? You have cosine minus 1. So we make it as cosine. Okay? So cosine twice an angle is 2 cosine squared, what? Half the angle, which is cosine minus 1, 1/5, minus 1. Okay, this, as I told you, it will be 1/5, while this one will be 2 cosine minus 1, 1/5 times sine minus 1, 1/5. Very simple. This will be resulted in 1/5, 2, so we have 2, 25. Okay? Again. As I told you, this will be 1/5. This will be 1/5. Okay? And this 2, and this gives 1/5, so we have 2 times 1/5 times 1/5, which is 2 over 25. Now for this one, cosine minus 1, which is square root of 1 minus cosine minus 1, 1/5 all squared. Okay, so this one will be 1/5 all square. This one will be 1/5 all square minus 1 minus 1. It will be results in 24 over 25, which is 2 root 6 over 5. This will be 2 over 25 minus 1, which will result in minus 23 over 25. This one is minus 2 over 25 times this one. This will be 1 over 25. 1 minus will result in also 2 root 6. Okay, complete. I will leave one problem as an exercise, two problems as an exercise for you. Evaluate sine, cosine minus 1, 1 over root 2, and this is the first one. Second one, what is sine? Sine minus 1, 1/5, plus 2 cosine minus 1, 1/4. Okay, as you see, it is very similar. It is very similar to the one we have solved it few seconds ago. This is similar to this. So study this, the solution of this carefully. Then inshallah you will solve this very easy. Inshallah. Very simple problem. Second part. He gives us given sine alpha equals s squared minus t squared over s squared plus t squared, where s and alpha and t greater than 0. Prove that alpha equals 10 minus 1 s squared minus t squared over 2st. Okay? Or in other words, we need to prove that 10 alpha equals s squared minus t squared over 2st. How come? It's very easy. 10 is sine over cosine. You already have sine, so only you need cosine. And we show how to obtain cosine. As I told you a few seconds ago, cosine square root of 1 minus sine squared. First obtain cosine squared, simplify it, then take the root. First obtain cosine squared, simplify it, hence obtain the root. Okay, this is sine. Cosine squared alpha equals 1 minus sine squared alpha. So it is 1 minus squaring this. This squared is s squared plus t squared over and the numerator is s power 4 minus 2 squared 2t squared s squared plus t power 4. Common denominator s squared plus t squared. This would be s power 4 plus 2s squared t squared plus t power 4 minus s power 4 plus 2t squared s squared minus t power 4. T power 4 cancels t power 4, s power 4 cancels s power 4. This will be summed up for s squared t squared divided by s squared plus t squared all squared. This is cosine squared. So cosine alpha is 2st divided by s squared plus t squared. So tan alpha is sine divided by cosine, sine divided by cosine. So this will be cancelled with this, and we have s squared minus t squared over 2st. Therefore alpha equals tan minus 1, this quantity required to be proved. Okay, the next set of problems also needs simplification of the given expression to be only in x. It is still depends on the two factors of the inverse function. Okay, take care here, no separation. Okay, let us see. Well, he asks me to put sine 2 tan minus 1x in terms of x only. This as function of x only. No sine, no tan minus 1 and so on, no tan, no, only x. How come? Very simple. If we can obtain tan minus 1 or sine minus 1, it will be finished. How this come? No problem. Very simple. Very easy. How? Let us see together. This is sine twice an angle, which is 2 sine tan minus 1 cosine tan minus 1. Okay? No problem. If I can obtain sine, I can obtain cosine, as we said, from the simple relation under the square root. If you have sine, you can obtain cosine. If you have cosine, you can obtain sine. So it is very simple, very easy. As you see, cosine some angle, as we know, it is 1 over sec that angle. Right. Sec is the square root of sec squared. Here, sec squared tan minus 1. But sec squared is 1 plus tan squared. So tan will be cancelled. Tan cancels tan minus 1. So we will have 1 over 1 plus x squared. This is the cosine. What about the sine? Sine tan minus 1x is simply 1 minus cosine tan minus 1x all square. But this is cosine tan minus 1. So square root of 1 minus 1 over 1 plus x squared all square, which is 1 minus 1 over x squared. Simplify, you have x over 1 plus x squared. Okay, this is sine, this is cosine, so we'll have y, which is twice sine is x over the square root, cosine 1 over the square root. Simplify, it is 2x over 1 plus x squared. Okay, he asks us for tan. What is tan? Twice tan minus 1. As I told you before, and I warned you, this never equal 2x. We have to get rid of these two. Let this y. This is twice an angle. Tan twice an angle, which is, we said, I gave this before for you. I search for what we have already wrote. We have already wrote here. I'm looking before. Just a moment. Yes, I found it. Tan twice an angle equals twice tan the angle, 1 minus tan squared the angle. So we can write it directly. It is twice tan the given angle, tan minus 1x, 1 over minus tan minus 1x all squared. tan cancels tan minus 1, which gives us 2x. Tan cancels tan minus 1, which gives us 1 minus x squared. As I told you, without that 3 basics, you will suffer in this lecture. If you study well, the sine, cosine, tan of the most famous angles and the most famous trigonometric relations and the basic two relations of the inverse functions, everything will be very, very easy for you. As you see, these relations, golden rule, how to obtain sine, cosine from the other. Okay, so the sheet will be very, very simple and very easy for you, inshallah ta'ala. Okay, we have cosine twice sine minus 1. We have 3 relations for cosine twice the angle, as we said, either cosine squared minus sine squared, or 2 cosine squared minus 1, or 1 minus 2 sine squared. Which one is the most appropriate? The third one. Why? For sine to meet sine minus 1. So this quantity, this relation will be 1 minus 2 sine squared for sine minus 1x. Sine cancels sine minus 1, so we have 1 minus 2x squared. As you see, piece of cake. Also, we need to simplify sine tan minus 1x. I think we solved it a few moments ago, such a relation. Yes, this one. Okay, this one. Sine, but this is not a part of the other problem. This is separate. Sine tan minus 1 square root of 1 minus cosine squared tan minus 1. Okay? But cosine squared is 1 over 6 squared. 1 minus 1 over 6 squared. Tan minus 1. And 6 squared is 1 plus 10 squared. 1 minus 1 over 1 plus 10 minus 1x squared. It's finished. Tan cancels tan minus 1, so we have 1 plus x squared. 1 minus 1 over 1 plus x squared. Simplify x over 1 plus x squared. Okay. Sine minus 1x plus cosine minus 1x. If you are brilliant, inshallah, you can solve it from the first glance, من النظرة الأولى. How? This is 1. How come? Okay, sine minus 1 is an angle. X is a sine. Okay, cosine minus 1 is an angle. X is a cosine. Okay, let us consider x as half. Okay, x equals half. So sine minus 1 half is 30 degrees. Cosine minus 1 half is 60 degrees. So this will be 30 degrees plus 60 degrees. It will be, as you see, 90 degrees. Sine 90 is 1. Again. Let this x equals 1 over root 2. Sine 1 over root 2 is 45. Cosine 1 over root 2 is 45. 45 plus 45 is 90. Sine 90 is 1. No problem, no problem. A third example. Take x as root 3 divided by 2. So, sine minus 1 root 3 divided by 2 is 6 degrees. Cosine minus 1 square root of 3 divided by 2 is 30 degrees. Their sum is 90. Sine 90 is 1. Okay? We call these two angles complement, متممتين لبعضهما البعض. أي their sum is 90. So this is directly 1. But I don't remember this and I don't understand this. No problem. Directly. This is the sine of the sum of two angles. Expand. Y equals sine minus 1x, cosine the second, cosine minus 1x, plus cosine the first, okay, sine the second. No problem. This will result in x, so we have x times x. This part can be transformed to sine 1 minus sine minus 1x square, 1 minus cosine minus 1x square. So we have x square plus 1 minus x square times 1 minus x square. So x square plus 1 minus x square, which is 1. Okay? So as I told you in the beginning of this lecture, you have to be extremely acquainted with the trigonometric ratios, trigonometric functions. Okay? Don't worry, inshallah you will gain a great experience, inshallah ta'ala. But just trust in yourself and study well, and any question you need, inshallah, my assistance and me are waiting for all your what you need, inshallah ta'ala. Don't worry about anything. Don't worry. You are in a vacation now, inshallah. ربنا يسلم وينجينا من الظروف الحالية، وإن شاء الله everything will be good إن شاء الله. I leave for you two problems. Cosine evaluate y equals, or express in x only, y equals cosine half cosine minus 1x, and the second one cosine twice sine minus 1x plus cosine minus 1x. Okay, let us enter the fourth part. Also simple problem. He gives us given sine alpha equals sine alpha plus cosine alpha equals s, and sine alpha minus cosine alpha equals t. Required to be proved what? Alpha equals tan minus 1 s plus t over s minus t. Very simple. Piece of cake. Or we need, or tan alpha equals s plus t over s minus t. Tan alpha is sine over cosine. So obtain sine, obtain cosine, divide, you obtain this direct. How? Say this one, this is 2. Please add 1 to 2. Please, 1 to 2. What is your result? Add 1 to 2. Cosines cancel cosine. So we have 2 sine alpha equals s plus 2. Or sine alpha divided by 2. Now 1 is subtracted, 2 is subtracted from 1. 1 minus 2. What is your result? Sine cancels sines, cosine will be added together, so we have 2 cosine alpha equals s minus 2. So cosine alpha only Divide sine by cosine, sine divided by cosine, which is s plus 2 over s minus 2. This is tan alpha, so alpha is tan minus 1, this quantity. Thank you. Okay? The last part asks us for sine minus 1 x plus cosine minus 1 x. Prove that sine minus 1 x plus cosine minus 1 x. Prove. Well, we need verification. Is by 2. We have solved this few moments ago, and I prefer to leave it as an exercise for you. You can? Or I solve it for you? Okay, no problem. I solve it for you. Okay, let y equals sine minus 1x. Okay, this means that x equals sine 1. Y is the angle of which the sine is x. Y is the angle of which the sine is x. So x equals sine the angle 1. No problem. Okay, very nice. But as you know, sine y equals cosine by 2 minus y. Sine y equals cosine by 2 minus y. You don't believe? No problem. Expand. Cosine the first, cosine the second. What gives you 0? Why? Cosine by 2 is 0. This is cosine by 2 cosine y plus sine by 2 sine y. Okay? This is 0. Sine by 2 is 1, so it is sine y. Okay? So, but sine y is x. Sine y is x. Between this and this, cosine by 2 minus y equals what? Equals x. So by 2 minus y equals cosine minus 1x. But we have here in our assumption y equals sine minus 1x. Add by 2 equals sine minus 1x plus cosine minus 1x. Piece of cake. How come? As I told you, if you are not acquainted with the trigonometric relations, trigonometric functions, you will suffer from this sheet. Otherwise, it will be very, very easy to you. Someone of you may think another solution, but I don't prefer it, but I mention it for you. Take the sine of both sides. Take the sine of both sides. Okay? The sine of both sides is sine minus 1x plus cosine minus 1x equals sine by 2, which is 1. Okay? Here, this is sine the first, cosine the second, plus cosine the first, sine the second. Okay? All this is 1. Okay? This will be results in x, so we have x squared. The second part, cosine sine minus 1 is square root of 1 minus sine minus 1 x all squared times 1 minus cosine minus 1 x all squared, which is 1. So we have x squared plus, this is root 1 minus x squared. Okay? Times root 1 minus x squared, which is 1. Okay, this is, oh, take left hand side, no problem, left hand side, right hand side. Okay, this is x squared plus 1 minus x squared, which is actually 1. So this is verified or satisfied. Okay, but you may ask why you don't prefer this, because if this 5 pi by 2, you obtain the same result. Why? Because sine 5 pi by 2 is also 1. For taking, as you know, sine 30 degrees is the same as sine 150. Is this means that 30 is 150? No. If sine equals sine, this doesn't mean the argument like equals the argument. So I don't prefer this. Okay, so someone may say that it is 5 by 2. No, it is only 5 by 2. As I told you, these are complement to each other. If one 30, the other is 60. If one is 20, the other is 70. If one is 1 degree, the other is 89. Okay. Another problem. He asks us to prove that sine minus 1x equals tan minus 1x over 1 minus x squared. We need to prove this. No problem. How? He needs tan. So if I have sine and cosine and divide each other at 10, then I can obtain sine minus 1, tan minus 1. Let y equals sine minus 1x. Therefore, y is the angle of which is sine is x. So therefore, x equals sine y. Right. So this is and cosine y, as we said, 1 minus sine squared. But sine y is x. So we have root y minus x squared. But sine y is x. So sine over cosine, we have tan y, which is x over root 1 minus x squared. So y equals tan minus 1 x over 1 minus x squared. But y is sine minus 1. What required to be proved? Okay. I solve one other problem and I leave the one problem as an exercise for you. Just this one, and I leave this will be the last one, inshallah, and I give one as an exercise for you. He asks us to prove that tan minus 1x equals half sine minus 1 2x over 1 plus x squared. Okay, no problem. This is very simple. How? I start, as you see, I start with the simple part of the problem. Okay, I start with the simple part, which is tan minus 1. Let y equals tan minus 1x. Y is the angle of which is tan is x. So x equals tan y. Okay? Okay, no problem. As we know, tan, therefore x equals, or x squared equals tan squared. Very nice. But tan squared equals sec squared minus 1. Very nice. Okay. And so sec squared y equals what? 1 plus x squared, which is 1 over cosine squared. What you are doing, I am step by step, I'm going from tan to sine. How come? As you know, sine is raised by cosine. Cosine is raised by sec. Sec is raised by tan. So from tan equal to sec, means sec From sec I go to cosine. From cosine I obtain sine. Again, he needs a relation between tan and sine. Okay, I know tan is related to sec, and the sec is related to cosine, and the cosine is related to sine, as I told you many times. And we have direct relation between sine and the cosine through the square root. Okay, this part, sine equals square root of 1 minus cosine, cosine equals square root of 1 minus sine. So it is very simple relation between sine and cosine. Therefore, from here, cosine squared y is 1 over 1 plus x squared, right? But cosine squared is 1 minus sine squared, right? Yes. So sine squared y equals 1 minus 1 over 1 plus x squared. Okay, as you see, 6 squared, we said here 6 squared 1 plus square 6 squared 1 plus x squared, yes, right. What is 1 over cosine squared, right? Cosine squared 1 over right. 1 minus sine squared, right? So sine squared, right. Okay, simplify, we have x squared over 1 plus x squared. Okay, so y equals sine y equals x over 1 plus root x squared, right? So y equals sine minus 1 x over 1 plus x squared. This is 10. This is 10 minus 1. This is 10 minus 1. Right? But he asks us for another relation. Okay, let us try. This is another relation. Let us try. No problem. No problem. Okay. Okay, we start from again, y equals 10 minus 1, x equals 10y, x squared 10 squared, 10 squared 6 squared minus 1. These are another correct relations, but we need this one. Okay. X is 10y. Okay. Left hand side, y equals 10 minus 1 x, therefore x equals 10y. No problem. Okay, right hand side, is it also y or not? We'll discover together. Okay. Right hand side equals half sine minus 1, 2x means 2tan. Okay, instead of x, we'll set tan. 1 plus tan squared, what? Tan squared y. 1 plus tan squared is 6 squared, right? Half sine minus 1, this is 2 tan y over 6 squared, 1 over cosine squared, so we have here cosine squared, right? Cosine squared y. Very nice. So right hand side equals half sine minus 1, 2 sine y, cosine squared y. Okay, half cosine was squared, we have 2 sine cosine. This we have half sine minus 1, 2 sine cosine, but 2 sine cosine is sine twice the angle, half sine minus 1 sine 2y. Sine minus 1, we have 2 times 2y, which is y, which is the left hand side. Okay, good luck. The problem I am leaving to you, the problem is that, prove that, I leave this for you, prove that, what? Cotan minus 1x minus tan minus 1x equals pi. Okay, good luck, good wishes. Inshallah, see you in the next lecture. Inshallah ta'ala.